Okay, so yesterday we talked about exponent rules. We talked about multiplying numbers that have the same base, so multiplying exponents with the same base, expressions with the same base. We talked about dividing when they have the same base, and we talked about the power of 0. Today we're going to talk about negative exponents, and for us to understand this, we're going to start by putting, I'm going to tell you what happens when you put these in the calculator. So I will give you time to copy this down in class tomorrow if you just want to pay attention to what this says, but I will expect you to have done the problems I'm going to do down here in practice. So when I write this in exponential form, 10 to the 4th is 10,000. 10 to the 3rd is 1,000. 10 squared is 100. 10 to the 1st is 10. 10 to the 0, as we learned yesterday, is 1. 10 to the negative 1 is 0.1. 10 to the negative 2 is 0.01. 10 to the negative 3 is 0.001. And 10 to the negative 4 is 0.0001. Okay? Now, if I write these in fraction form, this is 10,000 over 1, 1,000 over 1. And again, this you can find just by putting those in the calculator. This is 100 over 1, 10 over 1, 1 over 1, 1 over 10, 1 over 100, 1,000th, 1 10,000. So that's how you would write these in fraction form. Now, 10 to the 4th is 10,000 over 1. 10 to the negative 4th is 1 over 10,000. So hopefully you guys are already kind of starting to see a pattern here. Let's look at it when we write it with exponents. Okay, if I write this with exponents, I already know that 10 to the 4th is 10,000, so this is 10 to the 4th over 1. 1,000 I know is 10 to the 3rd, so that's 10 to the 3rd over 1. 100 is 10 squared, so that's 10 squared over 1. 10 is 10 to the 1st over 1. 1 in this case is 10 to the 0 over 1. Now, this is 1 over 10. Well, I know that 10 is 10 to the 1, so it's 1 over 10 to the 1st power. This is 1 over 100. 100 is 10 to the 2nd power. 1,000 is 10 to the 3rd power, so this is 1 over 10 to the 3rd power. And 10,000 is 1 over 10 to the 4th power. Okay? So here's what I see. I see that when I have a positive exponent, it's on the top, and when I have a negative exponent, so a positive exponent is in the numerator position, a negative exponent is in the denominator position. Okay? So what does this mean? What this means is when I have a negative exponent, what I'm going to do, a negative exponent is a reciprocal. So a negative exponent, of course my pencil would run out of lead now. A negative exponent, click, 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 okay, there we go. Exponent is a reciprocal. And if you recall, a reciprocal is that flipped fraction. So the reciprocal of 2 is 1 over 2. The reciprocal of 1/3 is 3 over 1. The reciprocal of 4/5 is 5 over 4. So if what I could say is 2 to the negative 1 is 1/2. 1/3 to the negative 1 is 3 over 1. 4/5 to negative, well, 4/5 to the negative 1 is 5 over 4. Okay? So whenever we talk about a negative exponent, we're talking about taking the reciprocal. Okay? So let's take a look at some examples. I expect you to have this written down, and I expect you to do these examples with me. Okay? So let's take a look at some examples. Okay? So first of all, let's try this. Let's start with an easy one. Okay? 1 over x to the 5th. If I wanted to write that with a negative exponent, I would write that as x to the negative 5th. Okay? Let's take it in the other direction first. Okay? Let's say I had y to the negative 6th power. Okay? So, when I think about negative exponents, I think of the song, Should I Stay or Should I Go? by The Clash. We'll listen to that in class tomorrow. Should I stay or should I go now? I'm sorry you had to listen to that, but that's what had to happen. Because if you stay, it could be trouble. If you stay, it could be double. I don't know the words, but there it is. So when I look at a negative exponent, anytime I look at an exponent, it means it can't stay where it is. It's got to go. Okay? So right now, if I wrote this, remember, we talked about the invisibles yesterday. We have the invisible exponent, the invisible coefficient, and we have the invisible denominator. So y to the negative 6 is written as y over 1. Okay? If I want this to go, it has to go to the bottom. That's how I get rid of the negative. And if there's nothing up there, I put a 1 on top. Okay, let me try another example. Let's say I have 3 to the negative 4th power. That means right now, this 3 is on the top. It has to move. It can't stay where it is because it's negative, and I'm not allowed to have negatives in my final answers. So if I want it to move, if I want to get rid of this negative, I have to move it away from where it's at. So instead of being 3 to the 4th on the top, I'll have 3 to the 4th on the bottom. This also works when the exponent is on the bottom. So if I had 1 over x to the negative 6, let's say, well, does the 1 get to stay where it is? Yeah. So the 1 can stay up there. Does the negative x to the negative 6 get to stay where it is? No, because negative exponents tell me it has to move, it has to go somewhere else. So it can't stay on the bottom, it's got to go to the top. So it becomes x to the positive 6. And there's nothing left on the bottom, so I put a 1, which means that's x to the 6th. Now all of this is work that we may not end up having to show, but that's kind of like just thinking about what we did. Okay, let's do a couple more examples. Okay, let's do a harder one. Okay, x to the negative 2 over y to the negative 4. So I'm going to evaluate each one of these separately. And when I look at these, if I see an exponent, I'm going to look at every single one of them and say, should I stay or should I go? So I look at this x to the negative 2. Does it get to stay or does it have to go? Well, it's got to go because it's negative, so it's got to go to the bottom or the top. Wherever it is, it's got to go to the other one. So x squared, for it to become x squared, it has to move to the bottom. Now I look at the y to the negative 4th. Does it get to stay or does it have to go? It's got to go. So in order to get rid of these negative exponents, and we are not allowed to have a negative exponent in our final answer, in order to get rid of the negative exponents, I have to move them, switch them either to the denominator or the numerator, depending on where they are. Let's try a different one. This is a little different. X squared over y to the negative 3. Okay? So when I look at this one now, x squared, does it stay or does it go? Well, it gets to stay because the exponent is positive. So it doesn't have to move anywhere because it doesn't have a negative exponent. Negative exponents get to stay where they are. Now, y to the negative 3rd, does it have to stay or does it stay or does it go? Well, it has to go because it's a negative exponent. So for it to become y to the 3rd, it's got to move up to the top. There's nothing left but a 1 on the bottom, so my answer is x squared y to the 3rd. Okay? All right, let's try a couple that are more complicated. Okay? So, first off, just to take a stroll down memory lane, first we started by just looking at negative exponents. So negative exponent, if you see a negative exponent, it means I have to take the reciprocal, which means it has to flip. Either it has to flip down or flip up, depending on where it started. These two were negative on the top, so they were negative. There wasn't even a bottom. You had to draw the 1 to give it a denominator to write it in fraction form. And so the negative, in order to get rid of that negative, I had to move it to the bottom. Same here with 3 to the negative 4th. In order to get rid of that negative 4 exponent, I had to move it to the bottom so it could become positive. Likewise, if the negative exponent's on the bottom, you move it to the top. Okay? Same thing over here. This one was negative, so we had to move it to the bottom. This was negative, we moved it to the top. For this one, it was positive, so it didn't have to change. It got to stay right where it was, but this negative had to move. Okay? Let's try a harder one. Okay? Let's try this one. 2 over s to the negative 7th. Okay? I want you to really quickly tell me what you think this would be when I get rid of the negative. Okay, so when I do this, I evaluate each one separately. So I have 2. 2 has no exponent, but that means it has an invisible 1, which is positive, so it gets to stay right where it is. S to the negative 7 has a negative exponent, so it doesn't get to stay where it is. It has to move So if it's in the denominator, it's got to move up to the numerator. So that becomes s to the 7th. We have that 1 down there, which makes it kind of an invisible, and it goes away. Okay? Let's try another one. This one is a little crazy, so we're going to try this one. We're going to evaluate these one at a time. This one's kind of crazy, so that's why I'm looking at it. This one is 4x to the 3rd, y to the 0, times negative 2x to the negative 4, y to the negative 6. What? Okay. First thing is, we know we might have some fractions, so we're just going to draw ourselves a fraction bar. We're going to evaluate each one separately. Okay? 4 is on top, right? 4 gets to stay because it has an invisible positive 1 exponent. Okay? X to the 3rd, is that positive or negative? It's positive, so it gets to stay on the top. Y to the 0 is neither negative nor positive, but what does y to the 0 work out to? 1. So we're going to multiply that by 1. Now we're going to look at this one, negative 2. Now, what is the exponent of negative 2? The exponent of negative 2 is positive 1. If we don't see an exponent, it has a 1. Just because it's a negative number, we don't care if the number is negative. We care if the exponent is negative. So negative 2 gets to stay up on the top. Now, what about x to the negative 4th? Right now, remember, these are both over invisible ones. Does x to the 4th get to stay on the top? X to the negative 4th? No, it's got to move to the bottom to become x to the positive 4. What about y to the negative 6? Does it get to stay on the top? No, we got to move that one to the bottom so it becomes positive 6. Now I got all these numbers all over the place, so now I got to figure out what I'm going to do. Okay? So I have 4 times 1 times 2, so I'm going to multiply the numbers first. 4 times 1 times negative 2 is negative 8. I have x to the 3rd on the top. I have x to the 4th on the bottom and y to the 6th. Okay? Now, when I look at something that's written like this, what I do is I look at my x's. Do I have more x's on the top or more x's on the bottom? I got one more x on the bottom. So, how many more x's do I have on the bottom? 1. So I have negative 8 over x, y to the 6, because I have one more x on the bottom than I do on the top. This was a hard example, okay? But the point that I want you to get out of this, 2 points. Number 1, a negative exponent represents a reciprocal. We're going to do a ton more examples like this in class, don't worry. And that when you look at a negative exponent, what you're saying to yourself is, should I stay or should I go? When I'm going to evaluate each one. If it's got a positive exponent, it stays where it is. If it has a negative exponent, it's got to move. And likewise, if it was on the bottom and it's a positive exponent, it stays there. It stays where it is if it's a positive exponent, and if it's a negative exponent, it has to move from where it is. We will do a whole bunch more examples like this on Monday, and I hope you'll have a good weekend.